Hi, I'm Matthew from Code Intelligence, and in this video I want to show you how you can test a Spring Boot application using CI Fuzz. For this I use our CI Fuzz extension for VS Code, as can be seen here. The application I'm going to test is called WebGoat. WebGoat is a Spring Boot application by OWASP. It intentionally contains errors to demonstrate typical mistakes programmers can make. To test an application with CI Fuzz, the first thing you need to do is click on Create Fuzzing Project. This automatically generates a fuzzing build script for the project, based on the existing build script. CI Fuzz detects many different types of build systems, including Maven, Gradle, and Ant. Should the build script not be recognized, you can easily enter the necessary steps to build your system here. After the build steps have been defined, in this case Maven clean package, you need to initialize the project. In this step, CI Fuzz automatically detects all dependencies of the project. CI Fuzz also scans the application for the endpoints which are offered by the controllers of the application. This allows CI Fuzz to also detect what data formats are expected by the interfaces, for example JSON, XML, and REST. This in turn allows CI Fuzz to generate test cases which match the expected format, and thus gain deeper access to the application being tested. After initializing the project, fuzz tests need to be created. For this we select Spring Boot fuzz tests and give the test a name. Then we select the Spring Boot application we want to test. In the case of WebGoat, two projects are detected, WebGoat and WebWolf. We want to test WebGoat. Below you can see all the endpoints that CI Fuzz found during initialization. Now we can either fuzz all endpoints, or we can concentrate our efforts on selected endpoints. In this example, we selected Challenge 5 as the endpoint we want to test. After the fuzz target has been set up, we can switch to the dashboard to inspect the fuzz test that we just created. Here we can also start the test on our local machine. Before the test is run, CI Fuzz compiles the project using the generated build scripts to insert special markers into the code, so the fuzzer can monitor and get feedback from the program execution. This is the foundation for feedback-based fuzzing. On a technical level, this means the CI Fuzzer instruments the edges of the control flow graph of the program. After compilation, a Docker image is created in which the actual fuzzing is executed. Using the Docker image, we can easily migrate the fuzz test into the cloud or continuous integration system. Once the Docker image is built, we can start the fuzz test. While the fuzzer is running, you can see its status on the dashboard. On the left, the number of edges the fuzzer has found can be seen. The middle graph shows the number of program executions per second. The rightmost graph shows the number of inputs which were needed to achieve the coverage. In our case, a bug has already been found, and we will have a closer look at it now. Click on All Findings to get to the list of issues CI Fuzz has found. You can then select the finding you want to take a closer look at. In this case, CI Fuzz found a SQL injection. CI Fuzz figured out that the username Larry can be used to log on to the database. It's important to note that the string Larry was not found by using a pre-configured dictionary, but was derived autonomously using the feedback CI Fuzz gets through its program instrumentation. Using mutations, CI Fuzz generates both valid and invalid SQL statements as inputs. Since CI Fuzz also instruments databases, we can detect error states in the database and notify the user. This was our short introduction to show you how you can use CI Fuzz to test Spring Boot applications with very little manual effort. In other videos, we will show you how you can use CI-Fuzz to test C and C++ projects, and how you can integrate CI-Fuzz into continuous integration systems. Thank you for watching.